Hello, and welcome to the Sleepy Cosmologist. I'm truly happy you've arrived here. Perhaps you're resting, lights low, snug under a blanket, or simply savoring a peaceful moment. Maybe the noise of the day has quieted, and the stillness feels tender. Wherever you find yourself, I've created this place just for you, a quiet corner of the night, where curiosity and tranquility can coexist. Tonight, we'll explore one of the cosmos' greatest enigmas together, black holes, not hurriedly, not like a lecture, but as two friends gazing at the stars, letting the vast darkness draw their thoughts deeper and deeper. I've tried my best to keep this tale calm and soothing, but black holes are simply too intriguing at times. So if your mind sparks awake with wonder, don't fret. It'll settle back down, a bit wiser, and filled with awe. If you're enjoying this serene moment, I'd be delighted if you gave the video a quiet like, or even subscribed if you'd like more restful science tales. And if you're listening from somewhere special, a mountain peak, a small town, or your favorite cozy spot, let me know in the comments. I adore watching the map of bedtime slowly glow. This video, like all here, is for relaxation and learning only. It's not medical advice or professional sleep guidance, just a tranquil space to let your thoughts drift. Now let's begin. Lean back, breathe slowly, and gaze upward. The night sky stretches endlessly above you, old and full of mysteries. You can't hear it, but the stars whisper. You can't see it, but space isn't empty. It pulses with gravity, motion, and history. The stars you see aren't mere specks of light, they're messages from the past. Their light has journeyed for years, decades, even centuries, just to reach your eyes tonight. A star you see now may have vanished long ago, yet its light lingers, a final note from ages past, arriving late but still meaningful. And between those stars, in the dark voids where your eyes first see nothing, something else lingers. Black holes, you won't spot them. They don't send light your way. They don't glitter or glow. They move unseen, concealed in plain sight. Yet they're there, scattered like hidden punctuation in the universe's story. A black hole isn't quite an object. It's a space, a place where gravity reigns supreme. Picture something so dense, so compact, that even light, the speediest traveler, can't break free. That's a black hole, not a hole as we think of them in the ground, but a zone where time, light, and matter spiral inward, never to return. They form when stars die in certain dramatic ways. The largest stars burn bright and fast, ending in spectacular collapse. When their fuel runs out, they crumple under their own weight. Most stars transform into something softer, a white dwarf or a neutron star. Yet if the star is sufficiently massive, it collapses without restraint, beyond atoms, beyond light, beyond time itself. What remains, not a blazing core or a fading ember, but a void, a quietness bound by gravity. At this very moment, as you inhale and exhale slowly, countless black holes may be drifting silently through our galaxy. They could have traversed entire star systems. They might be tugging at distant planets you'll never glimpse. But imagine if I told you that occasionally, black holes encounter one another in the endless expanse of space, where everything appears motionless. Black holes shift, they wander, they revolve, they orbit. And when two black holes draw near, not swiftly, not abruptly, but over millions or even billions of years, they start to dance. Initially, the dance is languid. Their immense gravity locks them into mutual orbits. Like spectral partners twirling in the darkness, they spiral nearer and nearer, silently emitting unseen ripples. These ripples spread outward, through the very fabric of space, not as light, but as gravitational waves. Picture it like this. If space were a delicate taut fabric, like stretched silk, then two black holes in motion would tug and ripple that fabric. They'd send out faint, stretching waves that carry the tale of their movement across the cosmos. Those waves don't rattle your body or your seat, yet they pass through you, perhaps even now. If you could sense them, they'd resemble the faintest pulse beneath all existence. Eventually their orbit narrows, and the black holes plunge inward, accelerating until they merge, combining into a single larger black hole with a burst of energy unseen and unheard, only detectable in the silent warp of space-time. But we'll explore that later. Tonight is about origins, about stillness, about lying beneath the sky and recalling that even in silence, stories unfold. Perhaps the most exquisite part of this tale is its duration. Black holes don't hurry. They move with the patience of deep time, where 1,000 years is merely the opening note of a long, unhurried melody. The universe isn't rushing, and tonight, neither are you. So as you drift, remember this: somewhere far off, two invisible giants may be circling one another in the dark. They aren't battling, they aren't pursuing, they're simply gliding slowly, quietly, drawn together by something ancient and inescapable, a force as old as the stars. You don't need to grasp every detail to sense the poetry in that. Just breathe, let your thoughts wander with them, let your mind flow like starlight, slow, weightless, unbound. And as we rest in this quiet awareness, a new question arises, tender yet insistent, hovering just beyond the edge of thought. What truly is a black hole? Let's linger there next. So what truly is a black hole? You've heard the term. Perhaps it evokes an image, a swirling, a tunnel, an opening in space, perhaps a gateway. Yet a black hole isn't truly a hole, not like those you carve in dirt or discover in your clothing. It isn't hollow, it isn't even dark in the way the night is dark. It is gravity, pure, concentrated, overwhelming, so powerful that not even light, the swiftest entity in existence, can escape it. To grasp the origin of black holes, we start with stars, not the small specks you glimpse in the sky, but the colossal, ancient giants that endure for eons. Stars form within clouds of gas, primarily hydrogen, drifting in frigid regions of space. When sufficient gas accumulates, gravity starts its silent task, drawing it inward, denser, hotter. At a critical point, the pressure grows so immense that hydrogen atoms fuse into helium. This fuels a star. Nuclear fusion, the inward tug of gravity countered by the outward surge of energy. It's a flawless interplay of pressure and radiance. For most of a star's lifespan, this equilibrium holds. But eventually, the fuel dwindles, fusion weakens, and gravity, ever patient, ever persistent, begins to prevail. In smaller stars, this collapse concludes gently. A white dwarf may emerge, scorching, dense yet stable. In larger ones, the end is far more spectacular. A supernova, the outer layers burst outward in dazzling brilliance, while the core implodes with unfathomable force. If the star was exceptionally massive, perhaps 20 times the sun's mass, the collapse doesn't cease. No pressure can withstand it. The core continues collapsing, beyond atoms, beyond protons, beyond comprehension, forming a black hole. Yet here's the peculiar part. The black hole itself lacks a surface, no solid exterior, no luminous layer. There's only a boundary known as the event horizon, the point beyond which nothing returns. Once something crosses that threshold, escape is impossible. Not light, not time, not you, not even a murmur can flee. Within, everything descends toward the center, toward what we term a singularity, a point of infinite density, where our equations fail and the laws of physics fade. It sounds terrifying, doesn't it? But a black hole isn't inherently destructive. It doesn't inhale matter like a vacuum. It doesn't wander the cosmos devouring stars. If the sun were swapped for a black hole of equal mass, Earth would orbit it just as steadily, only darker and far colder. You could even approach a black hole, and so long as you remained outside its event horizon, you'd sense a pull, certainly, but no immediate peril. From a distance, black holes are silent, motionless, patient. They don't pursue, they linger. Now consider this. Time warps near a black hole. Picture yourself floating close to one, while a friend stays far away. You hold up a clock. To you it ticks normally, but to your friend, your clock slows. Your voice drags. Your movements appear to occurring beneath the surface. This phenomenon is known as gravitational time dilation. It's not a fantasy, it's reality. Time genuinely moves slower in the presence of massive objects. Even on Earth, your feet perceive time slightly slower than your head, because they're a bit nearer to the planet's gravitational pull. The difference is minuscule, but it exists. Near a black hole, the effect becomes extreme. Imagine hovering just above its event horizon. You could witness millennia, even eons, pass for a distant observer, while mere minutes elapse for you. That's the peculiar wonder of black holes. They don't just warp space, they twist time, reshaping the very fabric of existence. You might ask, if light can't escape, how do we confirm black holes exist? We don't observe the voids themselves but their traces. We detect stars circling emptiness, flung by an unseen force. We observe gas spiraling inward, heating until it glows brilliantly before vanishing beyond the event horizon. We spot X-rays, distorted light, and occasionally a silhouette like the one captured by the Event Horizon Telescope in 2019. The first glimpse of a black hole's edge. We witness how they mold galaxies, anchoring sprawling stellar arms, silently shaping the cosmos. They aren't destructive beasts, but more like archivists, silent custodians of finality. They collect matter, cling to it, and bide their time. Yet even in endings, there's beauty, for black holes are part of the universe's cycle. Stars ignite, stars fade, and sometimes from their demise, a black hole emerges. Then it lingers, observing, until perhaps it encounters another. When two black holes meet, something remarkable unfolds. They don't crash like debris, but entwine in a gradual, inevitable dance. Their gravities merge, their horizons stretch toward one another, and they unite not violently, but with immense unseen force. The energy of their fusion escapes not as light, but as tremors in space itself, gravitational waves. In the next section, we'll drift into that curious concept. What truly is gravity? How can you feel a tug without contact? What silent force pins you to your bed now and draws black holes together? Close your eyes. Inhale, exhale. The performance has only started. At this moment, as you rest, gravity surrounds you. It doesn't clamor like electricity. It doesn't rattle or yell. It's a steady, unseen presence, pressing you softly into your mattress, cradling your form, keeping you grounded as if whispering, "Remain." And so you do. Rarely do you ponder it. You needn't yet. Gravity persists within you. It flows through you every instant of your existence. It shaped you before your first breath. It directs the tides, guides the moon, and positions the stars. It is silent, yet it is not feeble. Indeed, gravity is what creates stars. It's the reason anything exists. Let's drift into that thought, gently, as the night grows darker. Picture the universe long ago, before galaxies, before planets, before light, only clouds, cold and spread out, motionless. Then in that quiet, a faint gathering, a slow clustering of matter, gravity starts its work silently, unhurried. It doesn't rush. It has endless patience. Over ages, longer than mountains endure, longer than oceans recall, these clusters grow denser. They draw more matter inward. They compress. Heat builds. Pressure mounts. Then suddenly, a star. Fusion ignites. Light floods the universe. That's gravity's work. The gentlest force, yet it sparks fire. But what is gravity truly? It's easy to call it a pull, an attraction between masses, but that's incomplete. That's just the surface. Imagine space not as emptiness, but as a soft, unseen fabric, an infinite stretch in all directions. Place something on it. A ball, a planet, a footstep. The fabric bends slightly beneath it. Roll a smaller ball nearby, and it moves toward the larger one. Not because the big ball pulls it, but because the fabric curves. This is Einstein's revelation. Gravity isn't a force acting across space. It's the shape of space itself. Mass tells space how to bend, and bent space guides objects' motion. That's why the moon doesn't crash into Earth. It follows a curved path, held not by a tether, but by the shape of space. Black holes are odd, because they aren't objects on the fabric, they're holes in it. Steep, deep curves, where even light can't escape. Their gravity isn't just powerful, it's extreme geometry. You're part of that geometry now. Earth warps space-time, and space-time curves softly around you. That's why you feel weight. Not because something presses down, but because space steers you toward Earth's center, and your body resists lightly. When you drop something, a pen, a pillow, an idea, you see it follow the lines space has shaped. You can't see those lines, but they're there, traced by Earth's mass, followed by every falling leaf and orbiting moon. Though it feels ordinary, it's anything but. Consider this: every time you jump, even slightly, you briefly defy an entire planet's pull. You rise, resisting gravity for a fleeting moment. Then you return, always back to Earth. Even astronauts in space are held by Earth's gravity. They're falling too, just sideways, fast enough to keep missing the ground. That's an orbit. Endless falling, without ever landing. The same goes for the moon. Satellites, stars, and galaxies all drift through the cosmos like fish in unseen currents, not pulled by strings or engines, but by the silent force of gravity. Black holes are the strongest of these currents. Their pull isn't a gentle slope, but a sheer plunge, a cascade in the fabric of space. Once you pass the event horizon, there's no return, not because something pursues you, but because space itself bends downward, and time shifts its flow. Occasionally, two black holes find one another across the void, drawn not by need or intent, but by the natural curve of space. Their gravity intertwines, and a slow, inevitable dance begins. No noise, no collision, just a steady orbit, lasting eons, like partners unaware they're dancing. Their motion sends ripples through space, gravitational waves, faint, delicate tremors that stretch and compress the universe. These waves journey through galaxies, carrying the tail of their spiral. Some may travel 100 million years, and pass through you unnoticed. You don't sense them, yet they exist. Whispers of black holes in motion, messages etched in gravity itself. Tonight, as you breathe, you're part of this story. Gravity cradles your breath, your heartbeat, the galaxies, and their slow spiraling arms. It is both familiar and mysterious, the most known force, and the least understood. So when you drop something, or feel your body sink into sleep, remember, you move through curved space, and gravity, silent as breath, guides you gently home. But if gravity can ripple, can whisper across the cosmos, what are these waves truly? How do we detect them? How do we know when black holes merge? Let's explore that next. Space holds a silence so profound, it seems endless. Yet stillness doesn't mean absence. Even in quiet, things shift, turn, and draw near. Somewhere in the cosmic depths, two black holes begin their spiral. Invisible not by choice, but because they absorb light. They are mass, not brightness. If you could see space's fabric, if your mind mapped its curves, you'd witness their slow, then quickening orbit. Not like dancers, but like whirlpools, pulling, tightening, nearing. This isn't chaos. It's a deep, patient rhythm. Each revolution brings them closer, and as they spin, they speak, not in sound, unheard in the vacuum, but in waves, gravitational waves. Picture a still lake, smooth and perfect. Now toss a pebble into it. The waves expand softly, steadily outward in every direction. That's how black holes behave. When they circle each other,
Their movement warps the very fabric of space. They emit ripples, immense and unseen gravitational waves, a script etched into space-time itself. These waves don't travel through space. They are space itself stretching and squeezing as they move. Each orbit of the black holes creates another wave, and every wave bears a message. We exist. We are in motion. We are merging. On Earth you'd never sense it. The waves passing through you are incredibly faint, tinier than a proton's width. Yet they exist. They bend you ever so slightly. For an instant they stretch and compress the space between your atoms. Then they continue onward. The black holes have performed their dance, and you've felt its echo, even if unnoticed. As their orbit narrows, the black holes whirl faster. The energy of their motion floods into space, and the waves grow stronger in gravity's voice. To us this strength is a frequency, a chirp, a rising pitch like a coiled spring. When scientists capture it, it almost resembles a bird's call into the void. But that sound isn't moving through air. It's not sound at all. It's motion. The motion of space, the murmur of a universe reshaping itself. It wasn't until 2015 that humanity first detected this dance. The tools were massive. Arms spanning kilometers, lasers reflecting between mirrors, measuring the faintest tremors in space. LIGO, the laser interferometer, gravitational wave observatory. It listened for silence, then it heard something, a ripple, a wave, a whisper that had journeyed for 1.3 billion years. Two black holes had collided in a far-off corner of the cosmos, and Earth, eons later, trembled slightly as their waves swept over us. For the first time we didn't just observe the universe, we sensed it. So the dance isn't just theory, it's real, recorded, witnessed in the quiver of instruments and the shudder of space. Two black holes once separate, find each other, pulled by gravity's rules, by mass and distance and time. Their spiral quickens, tighter, their orbits blur. Then the moment, the union, their horizons meet, their cores fuse, a single larger black hole forms. The final wave, the last ripple, radiates across the cosmos, a farewell, a birth cry, a memory. Yet even after merging, the new black hole trembles. It hasn't settled. It vibrates. A cosmic bell struck once, fading into quiet. This too sends out waves, weaker now, the final notes of a symphony billions of years in the making. So here you stand, breathing softly on a tiny planet, hearing a dance that unfolded when Earth's earliest creatures were just learning to dream. A dance unseen, a sound unheard, yet a tale that reached you all the same. Isn't that? It's astonishing how the most enormous, enigmatic objects in the cosmos, black holes formed from stars, can move with such perfect coordination, orbit in quietude, and unite with elegance, while their faint, peculiar echoes resonate through your very being. Tonight, the black holes lie still. Their tale has been whispered in waves, yet those waves, the undulations in space-time, continue their journey. They extend outward, far past Earth, beyond our galaxy, venturing further into the void. What composes them? What propels them so delicately, and so endlessly? To grasp this, you must perceive space not as a void, but as a substance, a structure, a silent expanse that flexes and flows. Let's drift into that next. Into the fabric cradling the universe. Time seems so constant here, doesn't it? Steady seconds, gentle breaths, the rhythm of your heartbeat, night settling over you like a shroud. But time is deceptive. It varies from place to place, and the deeper you sink into gravity's embrace, the more peculiar time grows. Tonight, we linger at the brink of something primordial, a black hole, observing how time warps not abruptly, but in a gradual surreal distortion. Picture yourself floating near a black hole. You're secure, not plunging in, suspended just beyond the event horizon, that unseen threshold, where space curves inward, and time starts to bend. You hold a clock. It ticks softly, 1 second, then another. All feels normal. Yet imagine a companion far off in weaker gravity, observing you through a lens. To them something odd unfolds, your seconds lengthen, your motions decelerate, your light dims, reddens, stretches. For them time flows quicker, for you it's unchanged. This is time's gentle warp, known as gravitational time dilation, a subtle yet profound revelation from Einstein's general relativity. Stronger gravity slows time, not figuratively, but truly. Time, seemingly steadfast, becomes pliant. Near Earth's surface, time inches slower than in the skies. GPS satellites correct their clocks, because time advances faster in orbit than below. Near a black hole, this gap widens immensely. Linger just above its event horizon, and your time could drag while the universe surges ahead. Float there briefly, and your friend might witness millennia. Return, and the world you knew would have vanished. Mountains reshaped, stars flared and faded, all while you felt but a fleeting moment. This isn't fantasy, it's fact verified, intrinsic to gravity's nature. And black holes, they represent the most intense manifestation. So what occurs when you pass the boundary? You glide past the event horizon smoothly, without disturbance. There's no abrupt change, no visible or tangible division. From your viewpoint, you descend inward naturally, yet to an outside observer, you seem to halt, motionless, trapped in time. Your form elongates, not physically, but temporally. You become a lingering imprint, forever hovering at the edge. In time, even your light is trapped, and you vanish from sight. Peculiar, isn't it, that something as ordinary as time can warp, extend, shatter? Yet in a sense, that's what renders time so tender. It adjusts, it obeys gravity, it decelerates when required, and as you remain still, your own time moves in its gentle cadence. Perhaps it's soothing to consider that time isn't fleeting, that it can move with you, that near immense mass, time grows unhurried. Now picture the instant before two black holes collide. They spiral faster and faster. The gap between them shrinks, and their combined gravity grows overwhelming. In that fleeting moment before merging, time nearly halts near their shared edge. If you could witness the final second before contact, it would stretch into an endless pause, a drawn-out sigh. But for the black holes, there's no delay. They meet, they unite, they fuse into one. The event horizon reforms, a new limit emerges. Time continues its silent passage, and in the surrounding space, the last tremor of their joining escapes, a gravitational wave, a quiet farewell. You, lying still, have always existed within time's current. It guides you from one instant to the next, from youth to now, from now to the future.
Yet black holes reveal that the current isn't uniform. It can trickle or surge, it can stall, it can bend. And maybe that's what makes time valuable. Not its speed, but its adaptability. It can linger for you, it can expand to cradle memories, it can slow at the brink of the unknown. So how would it feel to hover just above a black hole, to drift where time is thick and sluggish, where a single heartbeat spans an age, where gravity warps not just your path, but the moments between your thoughts? Would the quiet feel deeper? Would sleep unfold more gradually? Would dreams stretch endlessly? Or would time itself seem like a reverie? Tonight, time extends slightly for you, not due to a black hole's pull, but because your mind wanders softly, drifting, easing. And though the world turns and clocks advance, you're free to pause, to float, to stretch each second like a delicate thread, because sometimes the greatest strength lies in slowing down, in resting within the gravity of now. But if time can decelerate, can it ripple? Can we sense those tremors? Can we detect the faint waves from a black hole's embrace? Let's listen for them next. Let's discover how we caught the murmur of space quivering with recollection. Somewhere in the night, a star fades away. It does not scream, it does not waver in dread. It merely concludes its long glowing existence. To grasp the origin of black holes, start here, not in shadow, but in radiance. Every black hole starts as a star. Imagine one now, enormous, bright, aged. Its form is hydrogen, its core a fusion furnace burning for eons. It is not still. Its surface boils with flares and storms, yet within a fragile equilibrium persists. Gravity draws inward, fusion thrusts outward. The two remain entwined, not in conflict, but in silent harmony. This balance is vital, but no fuel is infinite. Eventually, after millions or billions of years, the star shifts. It exhausts hydrogen, then fuses helium, then carbon, then ever heavier elements until iron remains. Iron, unlike the rest, does not release energy when fused. It only consumes. The star can no longer sustain itself. The balance shatters. In that fleeting decisive instant, gravity prevails. The star implodes, not softly, not gradually. Its heart collapses. Atoms are compressed. Protons and electrons merge into neutrons. Light is imprisoned. Matter folds inward. The outer layers burst outward. A supernova, outshining galaxies for mere moments. A final defiant flare, then stillness. What remains hinges on the star's mass. If small, a white dwarf lingers, scorching and dense yet serene. If larger, a neutron star, a sphere the size of a city, so compact a teaspoon outweighs a mountain. But if the star is vast enough, far beyond our sun, even neutrons cannot halt the fall. The core plunges deeper, beyond defiance, beyond light, and there a black hole emerges. It does not erupt into being. It does not proclaim itself. It simply becomes a place where escape requires surpassing light speed. A realm where nothing comes back. Not light, not time, not sound. A boundary forms the event horizon. Within, matter spirals toward a singularity. A point so dense, so bizarre, that physics falters. Yet all this stems from a radiant start. A star, a blazing nuclear heart. A life spent in brilliance. This is not a tale of ruin. It is one of metamorphosis, of something so brimming with energy, it could not endure unchanged. You might ask how often this occurs. More than you imagine. In our galaxy alone, millions of black holes may drift, silent, unseen. They do not glow, they do not seek notice, yet they linger, waiting among the stars, weaving through space. Some arise from a single collapsing star. Others, far larger, may form from mergers, from galaxies clashing, from histories, piled one on top of the other. These are the colossal black holes, millions or even billions of times heavier than our sun. Nearly every galaxy harbors one at its core, including our own. Indeed, at the heart of the Milky Way, 26,000 light-years from where you rest, lies a black hole. It rotates slowly, drawing stars into its orbit. Invisible to sight, yet undeniable in its pull. It has existed for ages, longer than Earth's oceans have flowed, longer than mountains have risen. A testament that black holes are not merely endings, they are foundations. Even now above you, massive stars blaze. Some will fade quietly, cool and dim, but others, the titans, will collapse into black holes. They will vanish not with a cry, but with a bend. Their mass endures. Their gravity intensifies. Their light fades, leaving a new quiet in the cosmos. This silence is not hollow. It brims with gravity, with history, with the echo of a star that once illuminated the sky of a forgotten world. Perhaps one day, another black hole will drift close, and the two will circle, spiral, unite, sending out a message not of death, but of rebirth. So you see, black holes are not beasts, they are legacies, tales woven in gravity, born from light forged in collapse, carried forward in stillness. You witnessed one star's demise, yet even in that end, the universe is not silent. From that end emerges a tremor, a sign, a faint shift in the cosmic weave. The question then is, how do we sense that ripple? How do we detect, from such vast distances, when two black holes merge? Close your eyes. Breathe deep. Let us start to listen. Space holds no voices, no winds, no echoes in the void, yet the universe still speaks. It speaks through gravity, through motion, through form and cadence. When two black holes meet and begin their slow inward dance, their dialogue starts not with light, not with sound, but with waves. Picture space-time, the fabric of all existence,
as a calm, unseen sea. Most days it lies undisturbed, serene, but when something immense shifts, a star collapsing, a black hole spinning, or two merging, it sends out waves. These are gravitational ripples. They are not of water or air, they are space itself stretching and squeezing. As a gravitational wave passes through you, it subtly, ever so slightly, elongates you, then compresses you. Before restoring you, you won't sense it, you won't perceive it, but your atoms do. The space between them shifts briefly, faintly, exquisitely. Gravitational waves are the voice of black holes, their traces, their murmurs, their scale. They tell tales light cannot, for black holes do not glow, they do not reflect. Once formed, they emit no light, but they move, they spiral, they merge, and in their motion, they stir the universe. Like a bow, when pulled along a violin string, they cause space to vibrate. Two black holes circling each other do so without a sound, yet every revolution emits a ripple. As their orbit narrows, these ripples intensify, quicken, and draw nearer. It's a climbing tone, a celestial swell until the instant they collide, and the last wave echoes out. It isn't a crash or a burst, it's more like a single chime. That note, that tremor journeys through galaxies, through time, but how do we detect it? How can we sense a quiver in space so minute it's smaller than a proton's width? Because we've crafted tools that can listen to space's whispers. Meet LIGO, the Laser Interferometer Gravitational Wave Observatory. Two lengthy arms, each spanning 4 kilometers, forming a vast L. Inside each, a laser reflects between mirrors. When a gravitational wave passes, it slightly lengthens one arm and shortens the other. The light, incredibly precise, detects this shift. It produces a new interference pattern, a faint flicker, a murmur captured in light. That murmur is recorded, studied, turned into a sound we recognize, and it sounds like a chirp. Just like that, a faint chirp, marking the union of two black holes, perhaps a billion light-years distant, a delayed echo, yet perfectly preserved. When LIGO first caught that chirp on September 14, 2015, we verified what was once only theory. Black holes merge, they warp space, and those distortions reach us. We were listening, and the cosmos replied. Since then we've detected more. Countless events, each a new collision of black holes, each with unique mass, rhythm, and voice in gravity's tongue. Some were swift, light black holes in rapid motion. Others were colossal, slow, weighty spirals, ending in powerful waves. Some even stemmed from neutron stars merging, dense stellar remnants still glowing. These events delivered both gravitational waves and light, a harmonious pair. But black holes stay dark. Their tails unfold solely in movement. You can't peer through a telescope and witness a black hole merger. You sense it through space's tremor, through wave space-time, carries softly across emptiness. And the beauty is, these waves still travel. A merger from a billion years ago might just now reach Earth. It flows through us, through our world, through our very beings, then journeys onward to stars unseen, to galaxies beyond our grasp. Gravity holds memories, carrying them endlessly forward. You might ask, if space can ripple, can it also split? Can gravitational waves grow so fierce, they shatter reality's weave? The answer isn't as we imagine. Even the strongest waves we've found are gentle. The universe is immense, and its fabric bends. Waves traverse it, but don't rend it. They move like breath, like a rhythm, like the passage of time. Tonight, as you sleep, space continues to expand quietly, gently, all around you, not in turmoil, not in rage, but in tender recollection of distant events. Two black holes, separate, then close, then united, a tremor, a melody, a tale without light, and you are woven into that tale now. You've come to understand a language that speaks without sound, to ripples that hold memory, not message, and those ripples, if traced backward, guide us to something deeper still. What is this space that trembles? What material bends and carries these waves so far? Yet what composes space-time itself? Let's drift into that next. Into the fabric of the cosmos. The universe is alive with motion. Planets circle, stars blaze, galaxies whirl. But beyond the glow, beyond the visible ballet, there are tremors, faint and silent, in space-time itself. The echo of something colossal shifting, of black holes colliding, of gravity murmuring. These murmurs are not for our hearing, they don't stir leaves, they don't resonate through air. Yet somehow, we've learned to listen. On quiet stretches of land in Hanford, Washington, and again in Livingston, Louisiana, two immense ears span the earth, each 4 kilometers long, each crafted not from flesh and bone, but from laser light and stillness. These are LIGO's twin observatories, the Laser Interferometer Gravitational Wave Observatory, 2 sites designed to hear the universe exhale. And across the Atlantic in Italy, another detector, Virgo, listens as well. Together they form a growing chorus of instruments, attuned not to light or warmth, but to space's delicate shiver. Picture this: you shine a flashlight down a long corridor, you split that beam, sending light down 2 paths at right angles. At the ends, mirrors bounce the light back to its origin. When the beams reunite, they create a pattern, a mark of their journey. Now imagine a gravitational wave passes through the corridor. It doesn't topple the flashlight, it doesn't shake the walls, but it stretches one path slightly and squeezes the other. The returning beams are no longer perfectly aligned, their pattern shifts, and from that faint flicker of interference, we know something has stirred the fabric of space. That's LIGO's purpose. At its core, it's a tool for measuring distance, with breathtaking precision. How precise? LIGO can sense a change smaller than 1,000th of a proton's width. A shift so slight, it's like measuring the distance to the closest star within the width of a hair. This sensitivity is no accident, it's the fruit of decades of planning, of teamwork, of engineering that verges on art. LIGO and Virgo are built in pairs not just for backup, but for confirmation. If both detectors sense the same wave at nearly the same moment from slightly different angles, we can pinpoint its origin in the sky. We can confirm a ripple has passed, a tail began. These devices do not listen just once, they listen constantly, without pause, through every moment. Amid tempests and calm, they remain vigilant. They seek the slightest break in the universe's rhythm, and when it happens, they respond, not with noise, not in alarm, but with quiet acknowledgement. On September 14, 2015, they sounded in unison. For the first time ever, humans detected the echo of 2 black holes colliding. It lasted barely a fraction of a second, a subtle ascending tone. Yet that tone had journeyed from 1.3 billion light-years distant, 2 black holes circling closer, merging, uniting. Their final tremor, their last ripple, found us, and we were listening. That instant marked a new era for science. For millennia we observed the heavens with our sight. Telescopes brought clarity, cameras preserved its splendor, but light can be obscured, swallowed, concealed. Gravitational waves, however, penetrate all. They move through dust, through stars, through time, through you. They never halt, they never weaken, and now we can perceive them. Each wave we detect teaches us more. We've heard massive black holes merging, heavier than anticipated. We've heard neutron stars crashing, scattering gold and platinum across the cosmos. We've started charting the universe, not by its glow, but by its motion. It's as if we were deaf before, watching a mute film of existence. Then suddenly, sound, a sound without medium, a sound woven from space itself. Now that we've heard it, there's no turning back. New observatories are rising, Kagra in Japan, LIGO India, and eventually LISA, a spaceborne detector circling the sun, listening with arms spanning 2.5 million kilometers. Together they will create a worldwide network, a cosmic stethoscope pressed to the universe's heart, ever attentive. And perhaps someday, a wave will traverse your town, your house, your resting form. It will stem from some ancient clash of black holes that existed and vanished before Earth bore trees, before seas held life, and you won't notice. But LIGO might, Virgo might, the world might shudder briefly, and another story will unfold. You need not be a scientist to marvel at this quiet wonder, to stand in awe that we've crafted machines so serene, so steadfast they can detect the murmur of space-time. Tonight as you lie here, breathing softly, you share this world with instruments that never rest. They listen to the void, not for stillness, but for motion, for echoes, for truth. The waves they capture don't merely recount events, they reveal that space is not hollow, it has form, it has substance, it has grain, it can bend, but what truly composes it? What is this medium that shivers and shifts? Let's wander next into the gentle undulating weave that cradles every star. Close your eyes briefly and picture space not as nothingness, but as something pliant, a tapestry, a length of silk spread across the universe, sleek, arched, faintly glowing. This is space-time. It may seem abstract, even enigmatic, yet the concept is elegantly straightforward. Space and time are not distinct, they form a unified whole, an interwoven fabric. Every object in the cosmos travels through this medium. Picture yourself holding that silk flat and undisturbed. Now place a small sphere upon it. The material warps, a gentle hollow forms around the sphere. That hollow is gravity. Now roll a smaller sphere nearby. It veers inward, tracing the slope shaped by the first, not because the sphere tugged it, but because the contour of the fabric directed its motion. This is gravity's nature, not a distant force but a bend in the pliable geometry of space-time. Albert Einstein gifted us this vision. Mass and energy mold the space surrounding them, and space dictates how objects traverse it. It's a silent exchange. Here is the curve, says the planet. Then here is the route, answers the moon. Thus the moon doesn't circle Earth, because it's pulled by an unseen cord. It follows a trough in warped space-time, like a sphere circling a basin, steered by the terrain beneath. This fabric, this space-time extends everywhere. It anchors your body to the Earth. It binds Earth to the sun. It allows galaxies to spiral and spans between stars like untouchable threads. At this very instant, space-time is below you, around you, within you. Each breath you take flows through this unseen field, and every step you've ever taken has subtly distorted it. Even you, your mass presses into space-time, leaving the faintest impression. Now reconsider that stretched sheet. What occurs when something immensely heavy rests upon it? A planet forms a shallow depression, a star carves a deep pit, but a black hole, it doesn't merely create a dent, it forms a chasm, a drop so sheer that nothing, not even light, can ascend, not because light lacks strength, but because space itself folds inward. There is no outward path, only descent. This is why black holes remain unseen, not because they're concealed, but because the route light would follow to flee no longer exists. Yet even black holes don't rend the fabric, they curve it, they stretch it, they deepen it, and when they move, circling one another, they send tremors through this cloth. Gravitational waves. You've encountered them in tails, in the chirps detected by LIGO, in the undulations from colliding black holes. They aren't sounds in air, but shifts in the framework of reality. The fabric bends, it rebounds, and the wave travels onward. Space-time is pliant, not like rubber, but like water, capable of flowing, rippling, conveying motion across vast reaches. It yields to movement, yet maintains structure. It can cradle galaxies for eons, and still tremble at a whisper from two colliding black holes. It is the most subtle force conceivable. This notion of reality's fabric might seem metaphorical, yet scientists regard it as tangible. It forecasts phenomena. It clarifies why light bends near stars. It reveals how time warps near massive bodies. Even GPS satellites must adjust for space-time's curvature around Earth to remain precise. Without these minute corrections, your phone would lose its way in moments. So when you step outside and gaze at the stars, you're not merely peering into distance, you're observing structure, a silent, unseen framework that binds everything together. That faint glimmer in the night sky, its light has journeyed along space-time's curves, gently bent by gravity, steadily reaching your eyes. Its path isn't straight, but elegant, molded by every mass it passed, and your own path has been shaped by this fabric. Every stumble, every jump, every orbit, every drift into slumber, guided by the soft contours beneath you. You're traversing space-time now, even as you lie motionless, even in sleep, because time itself is woven into this fabric, and you're always advancing through it. There's solace in knowing space isn't void, that time isn't just a ticking measure, but together they form something pliant, something sculpted, something that cradles you. You're not adrift in emptiness, You're nestled in a delicate web spun from gravity and geometry. And black holes, those enigmatic hollows, are merely deep impressions in that web, where space-time folds inward, curling around itself, guarding its mysteries. So next time you close your eyes and sense stillness, recall that stillness is relative. You're moving through time, through space, through the slow, undulating fabric that enfolds the stars, stretching like silk that retains every mass, every instant, every ripple. And if this fabric upholds the stars and bears gravity's waves, might it also cradle something more? Information, memories, particles, the tales of what vanishes into a black hole. If a black hole consumes all, where does it all go? Do the things it devours vanish eternally, or does the universe preserve them? Let's ponder that next. Somewhere in the silent dark, far from any star or moon, two black holes orbit one another, not swiftly, not yet. For now their dance is slow, ancient, a rhythm that has spanned millions, perhaps billions of years to reach its climax. Each black hole warps the space-time around it. Two profound wells gliding through pliant fabric, stirring unseen tides. As they circle, they draw nearer, spiral tighter, accelerate, not because they hurry, but because the space between them dwindles. The fabric itself draws them in. This is the final act. Two behemoths in motion, the universe's heaviest objects entwined in an embrace. They don't collide like stones. They don't crash. Instead they tumble toward each other, repeatedly, nearer and nearer, until mere instants separate them. Their immense weight warps the fabric of space-time, so profoundly that time itself thins. The surroundings appear to accelerate, yet within their embrace, time crawls, the spiral narrows. The waves intensify, not in noise, but in gravity. You've sensed these ripples before, encountered them in prior passages. These are the gravitational waves, the undulations emitted when massive bodies traverse curved space. Now as the black holes draw near, the waves climb in frequency, swifter, mightier, until the concluding note is poised to sound. Then in a span briefer than a blink, their horizons meet, not softly, not fiercely, but utterly. Their edges fuse. The singularities within those points of boundless density merge. What remains is no longer two black holes, but a single larger, weightier, more tranquil one, and the cosmos trembles in reply. The last gravitational wave unfurls outward, a sharp, ascending chirp, a final sigh, one last tremor before the newborn black hole finds its equilibrium. That ripple journeys for eons, traversing galaxies, nebulae, stars, and one day, Earth through soil, through structures, through you, not with impact, but with elegance. A fleeting distortion in space-time, a brief stretch and compression, then onward. This is how we detect the clash of titans, not by sight, not by sound, but by sensing, by witnessing space itself shift. The chirp LIGO detects, the pattern Virgo verifies, is the last whisper of two black holes uniting. It endures mere fractions of a second, yet that sound reveals all, their mass, their distance, the duration of their dance before merging. You might wonder, what becomes of their mass? Does any vanish in the union? The answer is yes, though not as imagined. Some of the total mass doesn't contribute to the final black hole. Instead it transforms into pure energy, radiated as gravitational waves. At times this energy surpasses the combined light of every star in the observable universe. Yet we perceive no glow, no warmth, only the motion, the ripple, the tail. Post-merger, the new black hole shudders briefly, imperfectly spherical. It hums a fading tone, a celestial chime, calming after its strike. This vibration, too, emits waves weaker, yet just as tangible. Then at last, quiet. The new black hole rests, mute, whole. Nothing escapes, no light, no trace, only mass, only gravity, only the story etched into the waves that fled before the horizon sealed. In this hush, there is no sorrow. The cosmos does not mourn the two, for something new has arisen, a weightier black hole, a deeper pit, a fresh imprint on space-time. It may drift alone eternally, or perhaps encounter another, and the spiral may renew. The cycle is not ruinous, it is generative. The universe is, it reinvents itself through impact, through force, through undulations. You resting now, are not distant from this tale, because these occurrences, these celestial unions are not uncommon, they occur constantly. Every few moments, perhaps somewhere in the expanse, unnoticed, silent, yet not without effect. Each one emits a signal, a gravitational tremor, a shift in the fabric of space, and occasionally those signals find us, find you. When titans clash, they do not create sound, they create movement, they create remembrance, they create something different. Their dance concludes, but the tremor persists, and within that tremor lies a chronicle of time, of weight, of form, of what is lost and gained. The speech of gravity is exact, yet it is also lyrical. It does not employ words, but it narrates tales regardless. And so you may now ponder, if black holes unite, and forge something fresh and dispatch these elegant ripples, where do those ripples journey? How distant can they roam? Do they ever diminish? Or do they resonate endlessly in the delicate weave of the universe? Let us track one of those ripples into the void. Let us follow the reverberation as it travels through galaxies and stars and ourselves. Let us float into the lingering glow, into the force that remains when the titans have vanished. Black holes do not blaze, they do not glow, they do not emit light as stars do, and yet when they combine, when two become one, they unleash more power in an instant than 1,000 stars would across their entire existence. It is simply not the type of energy we typically perceive. It is not heat, not fire, not hue. It is gravity in motion. It is space itself bending, flexing, vibrating, like a silent bell that can only be sensed. Let us revisit briefly that final whirl. Two black holes orbiting each other, nearer, tighter, swifter. Their combined mass twists the space around them into steep undulating curves, and as they circle, they shed energy, but they do not release it as light. They release it as gravitational waves, undulations in space-time that convey energy outward at light speed. This is how the orbit contracts. This is why the spiral narrows. Each wave carries away a bit more energy, and the dance accelerates. You might picture gravitational waves as small couriers delivering parcels of motion to the cosmos, and when the black holes finally merge, those parcels become a deluge. In a fleeting instant, more energy is radiated in gravitational waves than all the light from every star in the visible universe combined. But you would not witness it. You would not sense warmth if you were close, say at a safe remove from the collision. At most you would feel the space around you softly stretching, then squeezing, then settling back to calm. The force would pass through you without a whisper. Let us briefly speak in figures. Picture two black holes merging, each roughly 30 times the mass of our Sun. After merging, the resulting black hole might measure 58 solar masses. Where did the other two go? Those two absent suns, they didn't disappear. They transformed completely into the energy of gravitational waves. E equal mov. Mov quote means energy is mass multiplied by the speed of light squared, and that speed squared is an enormous figure. Even a tiny amount of mass turns into a vast sea of energy, and here, it's not a small mass. It's entire stars turning into movement within the fabric of existence. But that energy doesn't linger. It moves outward, spreading in every direction through galaxies and nebula. After 1 billion years it might reach Earth. We don't perceive it. We don't shine. But the planet shifts ever so slightly, not shaken, not stirred, just stretched for the briefest instant. A single ripple, a whisper. What's astonishing isn't just the immense energy released, but how softly it arrives. Gravitational waves don't strike or scorch. They don't blast or dazzle. They pass through you as if you were light itself, woven into the fabric they traverse. Yet with careful instruments like LIGO and Virgo, we can detect them, measure them, hear the echoes of stars that turned to shadows and shadows that became waves. You might ask, where does this energy go? Does it journey endlessly? Mostly, yes. Gravitational waves weaken gradually, very gradually. They dim as they spread, like ripples on an endless pond. Some of that energy still travels, still moves. Perhaps one ripple now brushes a distant galaxy, touching stars unaware of the contact. Another may have already passed through you, too faint to notice, yet altering space just slightly, making you part of that fleeting moment. This is the subtle beauty of gravitational energy, unassuming, silent, enduring. It moves unseen, linking events across unfathomable distances. It reminds us that what occurred far away can still resonate here, even if we miss the beginning. Black holes in this sense aren't just endings, they're instruments. Each collision plays a note in the symphony of space-time, and gravitational waves carry that melody forward without needing an audience. They reveal what happened, when and how massive the actors were. All we must do is listen. So tonight, as you rest, consider the energy needed to fill the sky with stars. Now imagine that same force condensed into silence. No fire, no glow, just motion, yet somehow stronger, more lasting, riding waves that can't be halted, only traced. And perhaps the most remarkable part, we only recently learned to listen. We crafted tools with the patience of ancient trees and the precision of moonlight, and they confirmed, yes, the waves exist. Yes, the giants collided. Yes, the universe recalls. But energy is just one chapter.
The waves carry movement, and perhaps even memory, and this leads us to an even more puzzling question. When an object, whether matter, light, or information, is pulled into a black hole, does it vanish completely? Does the cosmos erase it? Or is there some hidden way the black hole preserves what it consumes? Let's drift into that enigma next, where science murmurs about data, disorder, and the lingering traces of light. After every monumental event, there is a hush. Once lightning fades and thunder fades, the world pauses. The atmosphere feels denser, moments stretch, the tempest moves on, leaving behind silence. The same occurs in the cosmos. Even in that soundless, frictionless expanse, a peculiar stillness follows every impact. When black holes combine, after their final tremor fades, quiet returns. Profound, vast, absolute quiet. The newly formed black hole isn't entirely motionless. Not yet. It trembles. It sways faintly, like a struck gong, like water disturbed by a pebble. These last tremors are delicate, yet significant. They emit a few final gravitational ripples, gentle echoes from the infant black hole as it settles into its altered form. Scientists refer to this phase as the ringdown, the period after the collision, when the remnant black hole adjusts, hums, and then finally quiets. It's difficult to imagine something as massive and dark as a black hole resonating, yet in the terms of physics, that's precisely what occurs, not with sound, but with movement. The event horizon, the unseen boundary from which nothing returns, shudders briefly. It isn't flawlessly smooth. It flickers, creases, then smooths again. If you could stand near it, close enough but not too near, you wouldn't witness these vibrations, you wouldn't hear them, but you'd sense them in the shifting contours of space-time. You'd feel space stretch and stabilize. You'd perceive time resuming its steady flow. Then, as though nothing had occurred, all would be still. The black hole grows silent, not because it forgets, but because it has nothing left to offer. No more movement, no more ripples, only existence, vast, mute, absolute. It has absorbed its companions. It has reconfigured itself, and now it lingers. What does it await? Perhaps another companion drifting toward it over eons. Perhaps nothing. Perhaps this black hole will stay solitary for the rest of time, and that's fine, because the tale doesn't truly conclude here. The ripples from its collision still journey outward. Even if the black hole forgets, the universe recalls. Gravitational waves expand in every direction, bearing the complete chronicle of the event, the masses, the motion, the timing, the energy. These waves are history, a narrative etched into the structure of space. No ink, no parchment, just distortion, just form, just truth, and we are deciphering that narrative. Every ripple that reaches Earth adds another passage to our expanding cosmic manuscript. We chart what remains unseen. We hear what remains silent. In this way we connect with the farthest reaches of time. Yet here's a curious thought. Despite all the chaos, the final black hole appears unremarkable. From the outside, there's no trace of its origins, whether it came from 2, 3, or countless black holes. Even the stars that birthed it leave no mark. Black holes bear no names or scars. Their past is not written on their surface. They are shaped by just 3 traits: mass, spin, and charge. Nothing more. This is the no-hair theorem, a lyrical way of saying they lack complexity, no distinguishing marks. They are pure form, clean, graceful, indifferent. But the cosmos remembers. The gravitational waves that reach us carry echoes of all that came before. Even if the black hole forgets, the space around it holds the record. This is the quiet contradiction of black holes. They wipe away their history, yet their movement reveals everything. Now in the calm, after the collision, let's pause and sense what it means to stand before something whole. No fire, no collapse, no motion, only stillness. The ripples have faded, the chime has ended. Space is flat once more, and the black hole, whatever it once was, now simply exists. It rests at the heart of warped space, pressing in like a thumb into clay. It draws not greedily, but inevitably. Anything that strays too near will vanish, not by choice but because the course was set long ago. It does not pursue, it does not decide, it merely allows. Yet not all is lost. Some matter, gas, and dust circling nearby may linger, glowing, heating, casting X-rays as it spirals inward. In that radiance we sometimes catch the black hole's shadow, a ring of light framing the void. That glow is not the black hole itself. It's the final glimpse before gravity claims it. The black hole stays concealed, even in its silent strength. So tonight you rest beside the hush of that storm. Not the clash, not the whirl, but the quiet that follows. It's not absence, it's presence, a silence with weight, a stillness with memory, a darkness that embraces. And as you drift to sleep, perhaps you picture yourself floating near the edge, watching space's gentle curves settle. No noise, no dread, just gravity as it ever is, binding, forming. But before this black hole took shape, there were signs. Before the quiet, it blazed as light, as fire, as a star. Can we see it now? Not directly, but we can trace its shadow. Let's search for it next. You've come this far. A star burned, it fell, it became something new, a black hole, mute and vast. Now your next question stirs. Soft yet distinct. Can you spot it? The solution, like many in the cosmos, is both straightforward and enigmatic. No, you can't observe a black hole directly, but yes, you can witness its effect. A black hole emits no light, it doesn't shine, it doesn't bounce back rays. Once something crosses its edge, the event horizon, it disappears from sight. Its light is dragged inward endlessly. So how do we confirm black holes exist? Gravity leaves traces, it warps trajectories, it deflects light, it alters movement. In astronomy, these subtle distortions and whirls reveal the unseen. Picture wandering through a woods, the animal remains concealed, but you notice snapped twigs, imprints in the dirt, a stir in the brush. You don't have to see it to know it was there. Black holes imprint similar signs on the universe around them. One of the first hints came from a star called Cygnus X1. Scientists observed something peculiar, a star circling emptiness. It followed a swift, tight path, as if tied to an unseen mass. Yet no partner was visible. Only X-rays streamed from that patch of sky, high-energy waves from an invisible source. What we witnessed was a star orbiting a black hole, and the black hole was consuming. When gas surrounds a black hole, it doesn't plunge straight in. It spirals, tugged by gravity, squeezed by friction, scorched to extreme heat. Before vanishing, it shines. This luminous whirl is an accretion disk, a final burst of radiance, before darkness claims the light. Though we can't peer inside the black hole, we can observe this fiery ring just beyond it. We see it twist, shimmer, and flare. Black holes also betray themselves in another way. They warp light. They don't just absorb it, they bend it around. Light from stars behind the black hole is twisted by its gravity, forming distorted halos and odd arcs. This phenomenon is gravitational lensing, a curving of light's path through space-time. It's as if the black hole were a gravity-made magnifier, warping everything behind it. Sometimes it forms rings of light, flawless circles created by bending starlight around the unseen mass. These are Einstein rings, among the strongest hints of something massive and hidden. So no, we can't photograph a black hole itself, but we can capture its shadow, and that's precisely what happened. In 2019, the Event Horizon Telescope, a worldwide array of radio observatories, produced the first image of a black hole's outline.
It lay in a galaxy named Messier 87, 55 million light-years distant. The image displayed a glowing ring with a dark core. That darkness wasn't the black hole itself, but the shadow of the event horizon, where light starts to plunge in. The void revealed the presence. This wasn't an ordinary photo. It didn't. They used visible light. It wasn't an instant discovery. Months of data gathered from telescopes across the globe, synchronized with atomic clocks, were meticulously pieced together by steady hands and thoughtful minds. The outcome was grainy, unclear, yet stunning. It wasn't just evidence of the theory, it was confirmation of the black hole's existence. The image spread worldwide, a dark void encircled by fiery light. Not an eye, not a gap, but something more profound. A silent declaration: here I am. You can't see me, but you witness my impact. Perhaps that suffices. Observing a black hole resembles watching wind move through trees. The wind remains unseen, but its presence is felt in the swaying branches, the whispering leaves. Black holes sway stars. They disturb light. They warp time. By focusing closely, we detect them through their influence. Even within our galaxy, this holds true. At the Milky Way's core, scientists have tracked stars circling an unseen dark point. A star named S2 completes its orbit around this invisible mass every 16 years. It approaches, then retreats in a flawless elliptical path. Its trajectory, speed and acceleration have been measured. From this we know without doubt that a black hole resides there, massive, weighing 4 million times the Sun's mass. It is perfectly dark, yet its pull is unmistakable. Perhaps the lesson is clear: not all reality must be visible. Some truths are revealed through their effects, their gravity, their imprint on surroundings. Black holes embody this, silent, unseen yet irrefutable. As you relax, picture that dark circle edged with light, pressing into space's fabric. You won't spot it in tonight's sky, but it exists. In an odd way, it perceives you, not with sight or thought, but through gravity, presence, the subtle force only the mightiest entities wield. Yet seeing is merely the start. The black hole at our galaxy's center and others like it don't just exist. They mold, they bind stars, they anchor galaxies. Could black holes be not just endings, but foundations? Next we'll explore the quiet titans within spiral arms and stellar whirls. Science sometimes feels poetic, not just numbers and tools but something deeply human, vast and hushed. In April 2019, the world witnessed such a moment: a faint ring, a shadow, an image that altered everything. It was the first direct view not of a black hole but of its imprint, its shadow, not mere darkness, but light's absence, a form outlined, not by substance, but by silence. This black hole dwells in Messier 87, roughly 50 million light-years distant. It's colossal, over 6 billion solar masses. For years astronomers theorized its existence. They observed energetic jets erupting from the galaxy's heart, streams of matter only possible if propelled by something enormous, rotating and unseen. Yet only when a colossal eye the size of a planet was formed, could they observe more closely. The Event Horizon Telescope, or EHT, wasn't a single telescope, but a collection. A web of observatories across the globe, in Chile, Hawaii, Spain, Antarctica and beyond, worked in unison, merging into one immense instrument. Each location captured radio waves from M87's core, not visible light, but waves beyond human perception. For 5 nights in April 2017, these telescopes fixed their gaze on the same spot in the sky. 2 years later, after processing immense data and endless patience, they unveiled an image. It wasn't crisp, it wasn't vibrant, it was hazy, golden, a fiery loop encircling a silent core. The world stopped to behold it. For the first time we didn't just accept black holes existed, we witnessed the space surrounding one. But what exactly were we seeing? Not the black hole itself, since no light escapes it. Instead we observed the photon ring. Light caught in tight orbit, looping the black hole repeatedly before racing toward us. The luminous ring forms as matter nearing the black hole heats up while falling inward, emitting a radiant glow. Some of this light curves around the black hole before reaching us, and at the center, a void. That's the shadow. Not a conventional shadow, No object obstructs the light. Rather, it's the outline of a point of no return, a trace of the event horizon. What made this image extraordinary wasn't just the discovery, it was the form. A flawless ring, precisely as general relativity foretold. Einstein's equations, penned over a century earlier, had sketched this in numbers. Now we saw it in reality. The theory had spoken, and the cosmos had agreed. There's something eerie about the image. You gaze into it, and it gazes back. Not with hostility, not with eyes, but with a quiet existence. It isn't an object, it's a location. A place where gravity warps time, bends light, and locks fate. Yet around it, chaos. Gas spinning near light speed, matter burning at billions of degrees, photons twisting along warp trajectories. A contradiction. Serenity within, turbulence without, a radiant wreath enveloping an abyss. What the EHT captured wasn't merely a photo. It was proof that the universe follows our predictions under extreme gravity. It was a principle visualized, a concept made tangible, yet it was also profoundly human. We didn't construct the EHT solely to validate theories. We built it to witness, to understand, to peer into gravity's core, and declare, "There you are, I see you." And when that image emerged, something extraordinary occurred. The world stood still, not just researchers, not just stargazers, everyone. They stared at that blurred ring, and sensed something timeless. Stir, a feeling of magnitude, of awe, of perspective. Even unclear, the picture conveyed a tale, that in the endless cosmos, there exist spots where light fades, where time bends, where matter yields to gravity, and we can still uncover them. Perhaps the most lyrical aspect was how far the light had journeyed. The radio waves forming that image departed M87 more than 50 million years ago. They traversed the void between galaxies, drifted past remote stars, slipped silently through cosmic debris, and were finally seized by instruments atop mountains and icy expanses, all so we could cradle a shadow in our palms. Even now, the EHT persists in its mission. It has shifted focus to the black hole at the heart of our Milky Way, Sagittarius, A smaller than M87, yet nearer, calmer, veiled by gas. That image will arrive, revealing another shadow, another capture, another ring, another boundary, where light surrenders. Tonight, as you rest, picture that ring, that blazing circle in the dark, circling in emptiness, shining from matter that never entered. It is no beast, it is no annihilator. It is the halt of descent, the limit of sight, a silent border, where space curls too tightly to flee. And in witnessing it, we don't merely watch the universe, we become part of it. For in every beam of light, there is a past, in every shadow, a form, in every warp of space, a signal. And that signal, etched into the light-reaching earth, murmured, even the unseen can be unveiled. Yet that colossal anchor, in M87, is not solitary. Many galaxies harbor one at their core, even ours. Why? Why do black holes dwell in galactic centers? Are they the finale, or the genesis? Let's journey next to the spiraling arms and radiant stars, to the hushed hearts that bind it all. Galaxies rotate, this much is known. Spiral arms stretch like ribbons across the void. Stars glide in graceful arcs, and gas clouds drift in their orbits. From a distance, a galaxy resembles a whirl of starlight, a cosmic pinwheel of dust and gravity. But if you soared toward its center, beyond the arms, beyond the stars, into the dense core, you'd encounter something peculiar. Not a radiant guide, not a gathering of stars, but silence, stillness. You'd find a black hole, not just in ours, but in nearly every large galaxy observed. Elliptical, spiral, lenticular, each seems to cradle a black hole at its core, a quiet titan spinning, waiting, anchoring. These are not like the smaller black holes born from collapsing stars. They are supermassive, millions or billions of times the sun's weight, yet they occupy little room, their gravity compressed into an unseen point. One might expect such mass to shred everything apart, yet it doesn't. It arranges. It molds the galaxy around it, not through force, but by mere presence. By drawing space into its rhythm, anchors movement with its mass, like the core of a spinning wheel, or the calm heart of a whirling dance. Now, consider our own galaxy. Concealed behind veils of gas and dust at the Milky Way's center lies a black hole named Sagittarius A. Invisible to the naked eye, its existence has been uncovered through radio telescopes, infrared sensors, and decades of study. This is no mere theory. Stars have been observed circling it, especially one called SOV-2, tracing an elongated orbit that brings it nearer to the black hole than Pluto is to our Sun. As it approaches, it accelerates beyond planetary speed, swifter than any man-made craft, defying logic, unless an immense force is tugging at it. That force is Sagittarius A, packing 4 million solar masses into a space no bigger than a star. Yet it remains silent, almost dormant. It isn't devouring stars, or blazing with X-rays, nor is it encircled by a fiery disk. It simply waits, not asleep but at rest, unless something drifts too close. Perhaps the most unexpected trait of supermassive black holes is their inactivity. They don't always consume, they can linger for ages. In galaxies like M87, the central black hole is energetic, drawing in matter and spewing jets spanning thousands of light years. In others, like ours, it slumbers, like fading embers, beneath ash. Even in stillness, it anchors its surroundings. The question arises, which came first? Did galaxies coalesce around black holes, or did black holes emerge within them? The answer remains uncertain, lingering at the frontier of knowledge. Some clues hint at mutual growth, where a galaxy's central black hole and its bulge share a proportional mass. It's as if they've been in dialogue since the dawn of time, shaping one another, not as cause and effect, but as partners. Stranger still, some of these black holes existed when the universe was young, less than 1 billion years old. Quasars, brilliant, active black holes, glow at the cosmos's farthest edges, improbably massive for their age. This suggests they might not just be stellar remnants, but also galactic seeds. Perhaps they aided galaxy formation, or rapidly expanded within them, feasting on early gas and matter. The reality could be both, or something yet unimagined.
What grows clearer is their influence. These black holes mold their galaxies, emitting winds, jets, and radiation. They temper star birth and manage gas flow. Too much activity, and they expel energy, stifling new stars. Too little, and the galaxy may fade into darkness. It's a silent dance, a gravitational equilibrium, enduring for billions of years. Tonight, as you sleep under the gentle whirl of the Milky Way, remember there is a black hole spinning at its core. You won't sense it. You won't witness it. Yet it keeps everything in order, not through force, but with quiet persistence. It isn't consuming your galaxy, it's holding it steady. It prevents the spiral arms from scattering. It guides stars into their paths. It waits, and in that waiting, it molds everything. It may seem odd that something unseen, something that appears to swallow light, could also be the silent designer of such splendor. But that's the enigma of black holes. They are both annihilators and creators, voids and frameworks. They show us that strength doesn't need to roar, that calm can be mighty, that gravity alone can craft marvels. So when you gaze at a galaxy in an image, its arms spread like cosmic dust, recall the center, recall the hush, recall the invisible black hole. It doesn't glow, but without it, the stars would wander, the galaxy's form would dissolve. That silence is order, and perhaps now you wonder, if black holes grow so vast, so silently, and endure so long at galactic hearts, what occurs when two galaxies converge? Do their black holes meet as well? Do they waltz? Let's glide into that question next, and observe the slow, inevitable spiral of union. In space's quiet, nothing seems hurried. Stars rotate, galaxies stretch across the emptiness. Black holes drift like phantoms. Everything shifts, but it does so in silence, with time's patience. Yet even silence has direction. Even stillness can tilt toward something. This is the tale of black holes not meant to stay solitary. Most begin alone. Formed from dying stars, they linger in darkness, tugging softly on nearby matter. But some, particularly the giants at galactic centers, aren't destined to remain isolated. Because galaxies move, they orbit, they sway, they drift, and sometimes they collide. You might picture galaxies crashing like vehicles on a road, but that's not quite accurate. Galaxies are mostly empty space. Billions of stars, yes, but each distant from the next. So when two galaxies merge, it's not a collision, it's a slow dance, a weaving of stars and dust, a drawing of arms, a bending of motion. From a distance it's breathtaking. A spiral tangling, stars strewn outward like sparks, and at each galaxy's heart, a black hole. When galaxies merge, these central black holes start moving toward one another. Not swiftly, not directly, but through gravity's murmur, they inch closer. At first they're far apart, tens of thousands of light years, but as stars swirl and settle, as orbits adjust, the black holes gradually find each other. They are massive, they are anchored, but the galaxy around them is shifting. Like vessels, trapped in an increasing current, they're pulled inward by the motion of all around them. It requires ages, millions or even billions of years, for them to near each other enough to sense one another directly. Yet when they do, the dance commences. This dance is not sudden, it's gentle, a gradual tightening, a growing attraction, like two performers on a vast silent stage, stepping closer with each measured turn. Initially, stars encircle the black holes, and these stars help dissipate energy, refining the orbit, drawing the pair nearer. As they approach, they emit gravitational waves. These ripples drain energy, hastening the inward spiral until they are near enough to unite. The full journey, from the first drift to the final collision, can span longer than humanity's existence. Still it unfolds throughout the cosmos. Even now, as you pause in this instant, galaxies somewhere are combining, and at their centers, two black holes start their quiet waltz. But why unite? Why not circle endlessly? It's about energy. Every orbit holds motion, and motion means energy. To merge, that energy must escape. First, stars and gas nearby absorb it, small gravitational pushes, like cosmic resistance. Later, gravitational waves take the remainder, distortions in spacetime radiating from their circling forms. As energy departs, the orbit narrows. As the orbit narrows, the black holes draw nearer, and when they're close enough, gravity dominates entirely. The spiral turns into a plunge. The plunge becomes a union. Picture two whirls in water, apart at first, then drawn together by the flows they generate. In time they blend into one, more powerful, deeper united. These mergers aren't chance events, they're inevitable. We believe they occur frequently in the universe's lifespan, and each time a larger black hole emerges, this may be how supermassive black holes expand, not just by consuming, but by merging. One becomes two, two become one, a silent, vast cosmic rhythm. So we search for clues, signs of merging galaxies, hints of black holes nearing one another. Sometimes we spot two galactic cores close together, each glowing with X-rays, both harboring active black holes. Other times we observe galaxies with distorted shapes, long streams of stars stretched outward like tendrils. In the future, with sharper telescopes and advanced tools, we might witness more of these black hole pairs mid-merger. Perhaps one day we'll capture the final moment, the last turn, the ultimate ripple. But even unseen, we'll detect it. Gravitational waves from these mergers journey through the cosmos. Some have already arrived, more are coming. Each wave whispers that somewhere, gravity prevailed, that two became one, that the quiet between, the cosmos is far from empty, teeming with movement. Picture tonight two black holes, one emerging from a spiral galaxy, another from a distinct stellar cluster. They wandered for ages, orbiting in quiet. Now they draw near, unseen yet unstoppable. There's no hurry, they take their time. Their dance is slow, but its conclusion is certain, and when it arrives, it will reshape the universe. Consider this: as they merge, as their boundaries meet, what becomes of what lies within? What of the stars they swallowed, the particles, the light, the fragments of existence? Does a black hole ever disclose its secrets, or does it erase them? Let's drift toward that enigma, into the core of a question even science struggles to answer: what lies inside? Some questions can be studied, measured, tested. Others linger like distant stars, visible yet untouchable, real but shrouded in wonder. The mystery of a black hole's interior is one such question, a faint murmur in the laws of physics, a line we recognize but cannot cross. Even imagination falters without the framework crumbling. Yet tonight, we inch closer. Recall the event horizon, the point of no return. It's not a barrier, not a shell, just a zone where escape vanishes. Light that enters cannot leave. Time that enters bends inward. To an outside observer, nothing seems to change. An object nearing a black hole appears to slow, its light reddening, dimming, vanishing. From afar, the fall never concludes, it just halts, fades. But for the falling object, the tail diverges. Crossing the horizon, you'd feel no shift, no jolt, just an unseen line. You pass through effortlessly. Yet from that instant, retreat is impossible. Space twists so profoundly that every path leads inward. You can't reverse. You can't stop. You're drawn toward the center, relentlessly. That core is the singularity. Not a place as we know it, but a point where density turns infinite, where physics equations logic fail, where time crumbles and space blurs. It's not a dead end, it's where the path dissolves. We don't know what occurs there, perhaps never will. Some theories propose quantum mechanics might temper the singularity, that what we call a point could be something else, a structure, a realm, still enigmatic, but not boundless. Others think undiscovered laws will one day unveil the black hole's heart, that Einstein's relativity, though profound, may not hold the final word. It functions perfectly up to this point, and then passes the enigma to something more profound. Yet until that time arrives, we can only articulate what we comprehend. And what we comprehend is this: once you pass the event horizon, your destiny is fixed. You cannot send messages outward, you cannot halt your descent, and time from your perspective continues its relentless march. Here's something even more peculiar. Within the black hole, space and time appear to exchange roles. Time drags you inward like a force of gravity. You don't plummet through space, you plunge into the future, and that future in this scenario culminates at the singularity. No matter your actions, no matter how you struggle or maneuver, it is the future that pulls you there. Thus your journey is not merely physical, it is temporal. You aren't just traversing space, you're navigating an unavoidable moment. So what becomes of the objects that fall inside? A planet, a ray of light, a spaceship, a solitary particle. Where does it end up? Is it annihilated, crushed, preserved? This is where physics starts to contradict itself. Quantum mechanics maintains that information cannot vanish. If something exists, its properties, its state, spin, energy, can be altered, dispersed, rearranged, but never erased. Black holes, however, seem to obliterate information entirely. Once something crosses the horizon, all specifics disappear. Only mass, spin, and charge persist. Everything else, the history of the object, is lost. This conflict is known as the information paradox, and it remains one of the greatest enigmas in modern physics. Some theorize the information is retained on the event horizon's surface, like a celestial hard drive, encoding every detail of what has entered. Others suggest information leaks out gradually, as the black hole dissipates, a phenomenon called Hawking radiation. Still, some believe our entire framework must evolve, that space and time are composed of something more fundamental, a web of connections, a quantum structure we've only started to perceive. Whatever the reality, black holes push us. They compel us to face the boundaries of our knowledge, and how we acquire it. They are not merely objects, they are frontiers. Frontiers of physics, frontiers of thought, thought for the edges of comprehension. But perhaps that's what grants them their power, not just their gravitational pull, but their enigma. They remind us the cosmos isn't obligated to provide answers, that some truths are veiled within deeper truths, that we can approach and still miss the core. So tonight, as your breathing slows and your mind turns inward, envision the interior of a black hole, not as annihilation, but as profundity, not as obscurity, but as an inquiry, a realm where rules unravel, where movement transforms into time, where conclusions are origins folded into themselves. You cannot venture there, you cannot return, yet it persists, and the mere existence of such a place, concealed in the silent hearts of galaxies, scattered across the night sky,
is enough to awaken awe. It signifies the universe has hidden corners that remain beyond the grasp of certainty. It implies there are still enigmas to lose ourselves in. Yet another question lingers. If black holes absorb and trap so much, do they ever release anything? Do they expand endlessly? Or do they too, eventually meet their demise? Let's drift softly toward the slowest, most silent fade conceivable, the last whisper of a black hole. Black holes expand. This much is undeniable. They consume stars, gas clouds, even entire companions, if they stray too close. And when black holes collide, they don't negate each other, they merge. They form something bigger, denser, more profound. Expansion is intrinsic to their being, but how far can they go? Is there a boundary? A moment when the black hole declares, no more, or could it continue devouring indefinitely, surpassing galaxies, eclipsing light itself, becoming an infinite void at reality's core? To unravel this, we must journey through a black hole's prolonged existence. We observe it feed, we observe it bide its time, we observe it evolve. Growth starts modestly. A black hole birthed from a dying star might only be a few times heavier than our sun, yet if encircled by gas, it begins to accumulate, drawing matter in gradually. This isn't a chaotic process. Matter doesn't plunge directly inward, it spirals, creating a luminous disk. It heats, emits X-rays, glows fiercely before vanishing. This radiance is how we detect black holes in far-off galaxies, not from the void itself, but from its banquet. However, there's a threshold to how swiftly this consumption can occur. If a black hole devours matter too rapidly, the disk's radiation resists, dispersing some of the gas. This equilibrium, known as the Eddington limit, acts as a natural brake on black hole expansion. It doesn't halt growth, but it tempers it. Still over eons, even gradual feeding accumulates. Then come the mergers. When two black holes entwine, their masses don't vanish, they unite. A 30 solar mass black hole and a 40 solar mass one may fuse into a 68 solar mass entity, with a fraction converted into gravitational waves. It's not mere addition, it's metamorphosis. Over time these unions compound, particularly in galactic cores where black holes cluster and gravity binds them. This is how we believe supermassive black holes arose, not instantaneously, but incrementally, star by star, merger by merger. Now some weigh billions of times more than our sun, silent titans anchoring entire galaxies, unfathomably massive, yet unseen. But even supermassive black holes don't grow infinitely. Eventually, their fuel depletes, the gas dissipates, the stars stabilize, other black holes lie beyond reach, and so they slumber. Scattered across the cosmos, dormant black holes linger. They've consumed all within reach, and now they wait. They're not lifeless, merely idle, still potent, but with nothing nearby to draw in. It may take eons for something to wander close enough. Another star fades, another cloud drifts, another black hole vanishes, and when it happens, the stillness shatters briefly before settling once more. Yet black holes transform in another way, not by expanding, but by diminishing, a gradual fading. This concept emerged from Stephen Hawking, a physicist who perceived what others overlooked. He proposed that black holes aren't completely dark, that they emit something minuscule particles near the event horizon, known as Hawking radiation. This process lets black holes lose energy not in surges, but in the faintest, slowest seep, a whisper of energy returning to the cosmos. The tinier the black hole, the quicker it radiates. The larger, the more sluggish the escape. One the size of a mountain might disappear in an instant, a mere flicker in cosmic terms. But a supermassive black hole could outlast the universe's current age before losing even a fraction. Still, Hawking's insight was profound. It revealed that black holes may not endure eternally, that even the darkest voids eventually wane. So we reach a conclusion, subtle, yet clear. Black holes expand. They collide. They consume. But they also linger, and over eons, they dissolve. Not violently, not through decay, but through a quiet, prolonged release of quantum energy into the void. Picture it trillions of years ahead, when stars have dimmed and galaxies lie dark. Black holes persist, silent, enduring, until even they begin to fade. one by one, a murmur at a time. They surrender their heat, their distortion, their history, until only radiation lingers, and even that fades. It's the gentlest of endings, not annihilation, but reunion. Black holes don't resist the end of time, they sigh, and the cosmos grows still. So yes, they cease growing, not by choice, but because the universe falls silent. No stars left to devour, no gas to draw in, no companions to merge with, only time, stillness, and the last warmth of a shadow fading. And what follows? If black holes vanish and matter is gone, what remains? Just space, just echoes of what once existed, or is there something deeper etched into the cosmos? Let's wander there, beside the waves that persist long after shadows dissolve. To the ripples in the cosmic expanse, imagine a wave, not of water, not of sound, but a ripple in space-time itself. It doesn't gleam, it doesn't echo, it moves soundlessly, bending and squeezing all it touches, just slightly, just enough. It journeys not through space, but as space, bearing a tale, a tremor, a memory. These are gravitational waves, born from motion, from mass, from gravity's most intense moments. When two black holes spiral inward, they send out tremors, not in light, but in the fabric of the universe. And those tremors travel endlessly. They ripple through galaxies, across clusters, spanning light years of quiet. A few of these signals find their way to us. The first was detected in 2015, a fleeting whisper, a faint chirp captured by twin detectors, known as LIGO. Two black holes had crashed together more than 1 billion years earlier. Their waves arrived at last, so delicate, so slight, that they moved the instruments by less than a proton's width. Yet we sensed it, not with touch, not with sight, but through the art of listening. Machines with patient arms stretched across the earth, waiting to catch tremors from the stars. Since then we've recorded many more, each a tale. Black holes merging, neutron stars colliding, or something even more mysterious. Every signal is distinct, a singular mark in time, and the cosmos, it appears, is rich with these murmurs. What's astonishing is their endurance, their journey, their quiet persistence. Gravitational waves don't scatter like light, they don't dim as fast, they glide smoothly through space, slipping past gas, dust, even you. Right now, you are being stretched and squeezed by waves older than our planet. You don't feel it, they're too faint, but they never cease. And what do they hold? Not matter, not energy, as we know it. They carry knowledge, a trace of movement, of mass, of transformation. When we detect them, we're not just hearing history, we're touching it. A gravitational wave is space's way of remembering. Like a bell struck ages ago, the sound is gone, but the tremor lingers, a quiet whisper in the universe's hum. These waves are ancient. Some formed before our sun, before Earth cooled, before any mind ever wondered. Yet they still arrive in silence. True, you might wonder, if black holes fade, if stars dim, if all grows cold, do the waves end? Not quite. Gravitational waves aren't bound by heat. They don't burn. They need no fuel. Once born, they journey on unbroken. They weaken as they spread, but they never disappear. In the distant future of the cosmos, after the last light fades, gravitational waves may still ripple outward, bearing memories long after their origins vanish. Some researchers think the universe is brimming with them, a soft murmur from countless collisions and motions in the distant past. It's called the stochastic gravitational wave background, a cosmic whisper, woven from billions of tiny waves we can't distinguish. Each is too faint to hear alone, but together, they create a rhythm, a texture in the quiet, like the distant patter of rain. Perhaps one day, we'll craft tools sharp enough to hear that hum, to tune into the universe's full memory. Not just sudden events, but the quiet pulse of existence itself, the mark of time, the imprint of mass, the sigh of space. Gravitational waves reshape how we grasp the cosmos. Reveals that the universe is more than stars and particles. It is shaped by structure, curves, bending, and delicate rhythms. These elements link everything together, showing us that movement never truly vanishes. When objects collide, shift or end, their motion lingers, becoming part of the unseen fabric. Even now, researchers probe deeper, not only with LIGO and Virgo, but with future space observatories. These tools will drift silently among planets, measuring distances with lasers so precise they could detect shifts smaller than an atom over vast spans. Their mission is to catch lower frequencies, the slow resonant waves from colossal black hole mergers, the faintest traces of the universe's grandest encounters. Tonight, as you lie still, picture yourself adrift on this ocean, the ocean of warped space, unseen tides, and tales written in motion. You're not merely resting, you're carried by waves born from ancient lightless events. In that stillness, you're tied to something beyond sound, beyond light, to the universe's deep enduring memory. You may never witness a black hole collision, or feel a ripple firsthand, yet you are part of the fabric they traverse. In a sense, you are an observer. Each wave that passes through you leaves a mark, a silent sign that you too are in motion, even at rest. And so the echoes persist. Even as black holes fade, galaxies dim, and all else turns to darkness, the waves endure, holding the imprint of what once was, like footprints in unyielding sand. But where does this fabric originate? This bending space, this stretching time? Why does the universe curve? Let's turn next to gravity's essence, to what Einstein envisioned, what Newton sensed, to the unseen force that binds it all. What keeps the moon orbiting Earth, Earth circling the sun, and stars bound in galaxies? What shapes black holes, drives tides, and curves the expanding cosmos? The answer is quiet, steady, unceasing. It's gravity. Not a push, not a pull, not quite. More like a form, a dip in space, a warp in time. Tonight, it surrounds you, pressing you gently into your bed, anchoring you to this spinning world. Gravity, the softest yet mightiest force. You know it daily. It's your weight, the fall of rain, the flow of rivers. But what is it? For ages, we saw gravity as a force, an unseen tether drawing things together. Newton pictured it this way, a universal draw, like a thread connecting apples to trees and planets to stars. In part, he was right. His calculations held. They still do, but they weren't complete. Then came Einstein. With him a new vision. Gravity. It wasn't a force. It was the geometry of space. Large masses bend time and space. Planets, light and stars don't experience a tug. They simply follow the paths shaped by space itself, not pushed, just directed. Like balls rolling on a bent surface, objects travel along the curves created by other masses. The more massive the object, the deeper the dent, and the sharper the curve, the more closely things orbit it. This warping of space and time is explained by Einstein's general relativity, a brilliant theory, framed in terms of bending. It teaches us that where there is mass, space distorts, time stretches. Right now, you're in a slight gravitational dip. Earth makes a small one, the sun forms a bigger one, and black holes carve the deepest pits. In this view, gravity isn't a force, it's the structure of the stage where all matter moves. Picture yourself floating in space. You toss a stone, it drifts, not because something drags it, but because it follows a path, a geodesic, the straightest possible line in a curved universe. You float too, falling not downward, but along the same fold of space-time. That's why astronauts feel weightless in orbit. They aren't beyond gravity. They're immersed in it, moving with it, endlessly circling Earth. Gravity isn't missing, it's all around. But when you fall with it, you sense nothing. This concept, gravity as curvature, clarifies so much. It reveals why light bends near stars, why time slows in strong gravity, how black holes emerge, and how the universe grows. It even foretold gravitational waves, ripples we now detect from massive collisions. Each wave, each orbit, each falling object, is a mark of space-time's shape. And it's beautiful. Despite its complexity, gravity obeys simple rules. More mass means more curve. The nearer you are, the stronger the influence. Yet it's also the feeblest of the four fundamental forces, weaker than electromagnetism, weaker than the nuclear forces. A tiny magnet can lift a paperclip against Earth's entire pull. Still, gravity spans galaxies. It arranges stars into spirals. It binds clusters. It weaves the cosmic web, not through power, but through persistence, through presence. You might wonder, why does mass bend space? What is space composed of that it can warp? We don't fully understand. Space-time is a fabric we can map, but not yet explain. Is it made of something? Are there quantum threads beneath? Some believe so, at scales far smaller than atoms. Space might be grainy, like fabric seen up close, but we lack the tools to probe that deeply. For now we observe the curves from afar. We study their patterns, we obey their laws, and we ponder. Without gravity, there'd be no stars, no planets, no orbits, no time, at least not as we know it. Because gravity and time are deeply linked. In intense gravity, time crawls. A clock on Earth's surface runs a bit slower than one atop a mountain. Too slight to notice, but detectable. Even your phone's GPS adjusts for this. Each satellite signal is fine-tuned for the gravity where you stand. Einstein's theory is in your pocket. It prevents you from losing your way, and it's also in the stars, in every orbit, in every collapse forming a black hole. It shapes the universe, giving it order, harmony, and rhythm. Gravity binds galaxies, keeps planets aligned, and ensures night follows day. It's quiet, unhurried, yet relentless, never releasing its grip. Tonight, as you breathe under Earth's pull, remember you belong to a pattern older than stars. You rest on a planet that spins, because space permits it, because gravity calls it. You're cradled, not crushed, directed, not driven. You move along a curve drawn by light, mass, and time. The black holes we've glimpsed are merely the steepest bends, the sharpest folds in space-time. But gravity is everywhere, not just in those depths, but in your bed, your breath, the bones that hold you upright. And perhaps now you wonder, if gravity molds all, what shaped gravity itself? What existed before the curves? Before space? Before time? Let's wander into that question next. To the instant before beginnings, to the cosmos breath, just before the first star. Before stars, before galaxies, world or planets circled, there was only darkness. The infant universe, smooth and shapeless, no stars to glow, no black holes to warp, no atoms to assemble or names to utter. It was pure, it was boundless, it was all, and nearly nothing at all. Tonight, we journey there, not to time's start, but to story's origin. The universe, as we understand it, began in what we call the Big Bang, not a blast, but an unfurling, a sudden emergence of space and time, of energy and potential, not a location, but a moment, a beginning everywhere, simultaneously. In that first sliver of a second, the universe expanded quicker than light, a surge so swift we name it cosmic inflation. It didn't burst into space, it birthed space as it grew. Picture a balloon, its surface stretching. Now imagine that balloon is all there is. Everywhere you go, lies within that surface. That's space expanding. That's the young cosmos breathing itself into existence. It was searing, beyond comprehension. Particles raced in all directions. Matter and antimatter flickered into being, collided and vanished. For every billion pairs that dissolved, one particle endured. Those survivors, those rare remnants, would form everything. Stars, planets, people, dreams. And gravity was already there, threaded into the fabric, not yet sculpting stars, but observing, biding its time. For ages, hundreds of thousands of years, the universe was a radiant haze, a plasma, scorching and thick with light trapped among charged particles. Photons, the tiny carriers of light, couldn't move freely. They ricocheted endlessly, lost in a chaotic cosmic swirl. The universe was opaque, without stars or brightness, just heat and anticipation. But as it expanded, it cooled. When the temperature dropped sufficiently, protons and electrons combined to create atoms, mostly hydrogen, some helium, and a hint of lithium. For the first time, light could travel unimpeded. The haze lifted. The cosmos turned transparent. This primordial light, the earliest to journey through space, still lingers today as the cosmic microwave background. It isn't vivid or crisp. It's an ancient glow, diluted by time, murmuring to us from the instant the universe released light. Yet, stars had not yet appeared. The cosmos was a calm expanse of cooling gas, gently stirred by gravity's pull. Slight variations in density, almost imperceptible, began to amplify. Where gas was marginally denser, gravity intensified it further. Small clumps grew into clouds, clouds into knots, knots into nurseries.
The first stars were taking shape. It took ages, hundreds of millions of years, a vast cosmic darkness. But finally, gravity compressed clouds until heat and pressure sparked ignition. The first stars emerged. We call this cosmic dawn. In that initial blaze, radiant and blue, hotter and more massive than our sun, burning briefly before vanishing, the universe exhaled its first fiery breath. These stars pierced the void. They fused hydrogen into helium. They erupted in supernova, scattering space with new elements: carbon, oxygen, iron, the building blocks of all that followed. You are crafted from these materials, not metaphorically but literally. The calcium in your bones, the iron in your blood, the oxygen you breathe, all forged in the cores of ancient stars that lived and died before our sun existed. And those stars, those first luminous giants, were born from gravity, from silence, from patience. So gravity wasn't merely the designer of galaxies, it was the bringer of light. It gathered, shaped, and waited until fire could ignite. When the first stars exploded, their light surged outward, not just through space but through time. That light still journeys now, still stretches across the growing cosmos, still murmurs its story to astronomers who listen with mirrors and radio dishes, decoding photons like verses. And those early stars didn't shine alone. Gravity united them, clustering them together, laying the foundations of galaxies. At the hearts of some clusters, black holes began to form. Perhaps they arose from collapsing giants. Maybe they grew from dense matter pockets. No one knows for certain, but we know the first stars birthed the first black holes. The first light prepared space for the first deep shadows. All of this sprang from ripples, from faint irregularities in that early plasma sea. Patterns so subtle they might seem like noise. But gravity hears the noise. It discovers order in disorder. It crafts galaxies from murmurs. Tonight as you rest, recall this. There was an era before time was counted, a hush before noise, a void before brightness. Yet gravity was present, not as power, but as potential. It didn't forge stars, it allowed them. It didn't glow, but it ensured light would come. And within those early stars, black holes were forming. In the blaze, the collapse, in the radiance, the seed of darkness, all intertwined from the start. Now the question lingers softly. If black holes emerge from stars, from collapse and flame, could they arise from something else? Might black holes have existed from the very first instant, from the Big Bang itself? Let's linger beside the notion of primordial black holes, older than any star. There's a thought subtle and curious, that black holes might not only stem from stars, that some could have been there long before the first star ignited, before galaxies twisted, before atoms settled, before light could reveal their shadows. These are primordial black holes, not born from collapse, but from creation. Black holes not as an end, but as a start. To picture them we must journey far back to the earliest flickers of existence, right after the Big Bang, when the cosmos was not a canvas of stars but an ocean of energy, scorching, dense, shifting with unfathomable speed. The rules of physics as we know them were still forming, and in that fleeting, chaotic instant, certain regions of space may have crumpled inward, not from a dying star, but from the sheer density of energy itself. Tiny pockets so dense they warped space-time, carving holes into the infant universe, and if they did, those holes might remain. Unlike stellar black holes, primordial ones could have taken any size. Some might have been minuscule, no bigger than a proton, yet as massive as a mountain. Others could have been colossal, rivaling the black holes we observe today, unconstrained by a star's limits. They were molded by conditions no star has ever faced. But do they exist? That's the challenge. We've never confirmed one. We've never witnessed a primordial black hole bending light or disturbing space, yet perhaps we've glimpsed their traces. Some researchers speculate these ancient holes might account for the enigmatic dark matter enveloping galaxies, unseen, heavy, and omnipresent. We don't understand dark matter, but if primordial black holes are real, they could compose part of it. Small, silent, elusive, detectable only by their tug. Hidden murmurs cradled by gravity. Other clues may reside in gravitational waves.
Some of the black hole collisions detected in recent years involve holes heavier than stellar origins should allow. Too massive, too near. Could they be primordial, born not from? Could black holes date back to the Big Bang itself? The answer remains unknown, yet the idea persists like a faint haze at the boundaries of understanding. There's an eerie elegance in the notion that these cosmic voids, those profound pits in space, might predate light itself. That darkness didn't follow the stars, but preceded them. That even as the universe took shape, it curled inward in hidden ways, preserving those twists for eons. Some theorize these ancient black holes could have sparked galaxy formation, their subtle gravitational pull gathering matter into the structures we recognize today. If true, every swirling galaxy, every gleaming star, might trace its form to something primordial, unseen and nearly lost, an initial warp that shaped the cosmos. Others envision them smaller, specks adrift in the void, unnoticed. Most would have vanished swiftly through Hawking's process, but a few, just substantial enough, might linger, drifting unseen among stars, detectable only by the faintest tug on gravity's fabric. They could surround us, invisible, untraceable. Yet even if they evade discovery, primordial black holes push us to ponder questions as vast as the cosmos. They hint that the early universe was anything but serene. It was a tempest of creation, teeming with potential. In that turbulent space may have coiled tightly in spots, compressing time into a point, forging dark remnants from the universe's fiery dawn. They also prompt us to consider the diversity of black holes, stellar, supermassive, primordial, each born of different circumstances, each a unique collapse of space, a distinct end of time, yet all share the same quiet, the same event horizon, where understanding dissolves. Perhaps this enigma isn't meant to be unraveled, not now. Maybe primordial black holes serve as cosmic whispers, reminding us that even at time's birth, shadows existed, not sinister, not flawed, just profound, just the natural creases born of energy and possibility, the hush woven into every origin. Tonight, as you rest beneath Earth's gentle pull, picture the cosmos before stars, pure energy, pure space. Within that silent blaze, imagine tiny pockets where space curled inward, where time stretched thin, where beginnings folded into something deeper. Perhaps those folds still drift, unseen, undisturbed, and perhaps with every black hole collision, every ripple through space-time, we catch their faint reverberations. We seek them not just through lenses but with theories, equations, hypotheses, curiosity. We hunt for traces in the bending of distant light, in the quiet tremors of gravitational waves, in the slow dance of galaxies. In this search we expand, not just our knowledge of black holes, but our capacity to wonder. So we linger now in the thought that some black holes may be as ancient as existence itself, older than atoms, ancient beyond a measure of stars. Not forged from demise but from pure possibility, shadows not of endings but of beginnings. From these potential shadows, we turn to what is visible, the tale of black holes in motion, crashing, uniting, molding the universe around them. Though some emerge from darkness, countless others arise through movement. Let's glide into that now. To the waltz of colossal entities, to the unseen flows of orbit and destiny, to the rhythm of gravity. Before two black holes combine, before the last wave spreads through space, before space warps in their final union, there is a dance, a prolonged quiet circling path. Two massive forms spiraling endlessly, pulled by gravity, sculpted by time. They drift without sound. They never meet, not for ages. Yet with each revolution, they inch nearer. One might picture chaos, collision, destruction, but that's not how it starts. It begins in calm. Maybe they were once stars birthed from the same nebula. Maybe they burned side by side, sharing light for eons. Then one after another, they collapsed, their flames extinguished, their mass turning inward. What lingered was gravity, and gravity does not forget. They become a pair, bound in orbit, revolving around a shared core. At first the gap between them is vast, serene, undisturbed. Yet they pull at each other ceaselessly, softly, each loop releasing a faint tremor, a gravitational ripple, a whisper in space-time. These waves steal energy, bit by bit, just enough. As energy fades, the orbit narrows, the loop becomes a coil. this spiral may endure for ages. To the universe it appears unchanging. The black holes circle silently, endlessly, as if locked in time, yet in truth they are forever descending. Their paths grow closer, their pace quickens, the waves they send grow louder, deeper, more frequent, a gradual rise, almost beyond human comprehension. Finally they near each other, so close that light itself would strain to pass between. Their edges begin to sense one another, to bend in harmony, to foresee what must come. Now they move swifter. A last whirl of orbits, a blur, a surge at the brink of silence, then they fuse. From afar, this instant lasts mere moments. A burst of gravitational waves, a final signal caught by detectors on Earth. But within the orbit, where space twists most fiercely, the tale runs deeper. The dance becomes a plunge, the spiral folds, and two become one, not with noise, not with light, but with gravity. The new black hole born from this embrace is greater, denser, calmer. It steadies, it rotates, it lingers, and the space around it stills once more. We've captured these dances now, not with sight, but with tools. LIGO, Virgo, Cagro, observatories that hear rather than see. Each wave they catch teaches us. We chart we observe the masses, we follow the spiraling paths, we calculate the remaining solitary black hole. From these signs we perceive the universe's rhythm, its pull and movement. What's striking is how these black holes never collide abruptly. They come together gradually, through motion, through cycles. Each revolution a quiet preparation for the last, like partners circling a common point, barely touching until the final moment. There's poetry in the thought that a black hole's end starts long before the impact, in the silent dedication of their shared path, in the enduring attraction that can linger for ages. They do not hurry, they do not fight. They allow the dance to proceed at its own pace. Some black holes combine swiftly, formed near each other, with little distance separating them. Others may wander for eons, until galactic encounters or subtle gravitational tugs pull them closer once more. Yet always there is the dance, the steady circling, the pulse beneath the quiet. Sometimes the dance involves more than two triple arrangements, chains of orbits, groups of black holes shifting in chaotic yet bound steps. These intricate systems also produce waves, tangled, overlapping, erratic. Yet within them, order arises, gravity carves its course, motion reaches its conclusion, and always black holes unite. So tonight picture two black holes orbiting, not colliding, not hastening, but moving slowly, faithfully. They drift not out of necessity, but because the space between them calls to be bridged, and gravity is unhurried. It lingers, it listens, it pulls them nearer, without a sound. This dance unfolds not only in space but also in time. Each orbit is a beat, each ripple a tone, each merger a pause before a new melody starts. Even the silence that follows has cadence, even the calm holds remembrance. The black hole that remains is unlike either of its origins. It is something transformed, a fusion, a continuation. It bears the energy, the rotation, the tale, and though it stands silent, its history echoes in the waves it left behind. You may never witness this dance, yet the cosmos brims with it. Now, above and below, black holes are circling, drifting closer, enacting this timeless sequence, and one day long after you rest tonight, their dance will conclude, and a new ripple will emerge, a tremor through space, a murmur in gravity, a sign that even the darkest entities can move with elegance. And perhaps now you ponder, after the union, what awaits the black hole? Does it remain still forever? Or does something more enigmatic linger at the fringe of all we grasp, hovering near the last page, the gentlest inquiry, the border of physics and what lies past? The universe holds boundaries not built of barriers or marks in the heavens. They are formed by limits, limits of vision, of reach, of understanding. Among the most enigmatic is the event horizon, the unseen border enveloping a black hole, not a shell, not a boundary, yet a point beyond return. Pass it, and there's no turning back, no light, no sound, not even the flow of time. Throughout this voyage, we've orbited that edge. We've witnessed black holes emerge, collide, expand and vanish. We've heard their echoes, sensed their gravity, and pondered their depths with quiet awe. But what exists past that line? What becomes of the space within, the mysteries it guards, the data it conceals? And does that border truly erase what enters? Some scientists disagree. They argue nothing is ever truly gone. That information must persist, even if distorted, even if reshaped. Maybe it lingers at the horizon, imprinted like waves on water. Maybe it seeps out gradually, woven into the faint glow of Hawking radiation. Or perhaps our laws are incomplete, and new truths lie just beyond our grasp. Others propose something more profound, that a black hole's interior may not be void, but vibrant. That space might twist, fold or reconnect. That black holes could be gateways not to oblivion, but to something new. Another cosmos, another dawn, a different kind of reality, still cloaked in equations and wonder. We don't know, we can't, not yet, but the horizon urges us to keep questioning, for that's the heart of science. A quiet push of curiosity against the limits of knowledge. It's not always about answers. Often it's about the beauty of the questions. Black holes harbor the deepest ones. So we leave them as we met them, not solved, but cherished, held in fascination, held in reverence, held in the delicate balance between observation and imagination. They don't speak, yet they alter everything. They mold galaxies. They bend time. They shape us. As you breathe softly now, cradled by Earth's pull, resting in the quiet between thoughts, remember this. You've journeyed far, from the first murmurs of the night, to the ballet of colliding black holes, to the whispers of the ancient universe. You've drifted across time and space, arriving at the brink of all things, and here, where understanding fades, serenity begins. Release, for now, the need to unravel. Let go of light, let go of gravity, let go of time. You're safe. You're still. You're part of a cosmos that holds you tenderly, even in its silence. And if your eyelids grow heavy, if your breath slows and your mind drifts like stardust through dimly lit galaxies, that's perfect. It means you've listened deeply, you've wandered far. Now your thoughts can spiral inward too. Before you slip away, if you've savored this quiet voyage through stars and shadows, I'd be so thankful if you'd offer a kind like, or perhaps subscribe for more soothing science like this. It helps other weary minds find their way here. And if you wish, leave a note sharing where in the world you're listening, and the hour there. I adore watching this sleepy tapestry of listeners unfold, like galaxies scattered under a peaceful night sky. Grateful for your wonder, your quiet presence, your companionship. No matter your location or what burdens you hold this evening, the cosmos holds you in return. Rest easy, and until we meet again in the void, among the stars.